Right, kiddos, we've solved systems using a variety of ways, and lastly, we're going to be using tables and alligators. So we have two tables here, one for each alligator. And what I'm going to go ahead and do is label alligator 1 as L1, and we'll label alligator 2 as L2. So now when I graph them, I can see my different lines. So to graph alligator 1's line, we've got our ordered pairs here, 0, 4, 1, 5.5, 2, 7, and 3, 8.5. So I'm going to go over to my graph, and I plot 0, 4 first, and then 1, 5.5. We've got 2, 7, and then 3, 8.5. And then now I'm just going to connect a line between them. And we'll go ahead and label that as L1. L1. And then for alligator 2, we've got our ordered pairs over here. So we start with 0, 6, and then 1, 7, 2, 8, 3, 9, and then now let's go ahead and connect those dots to make our line. And we'll call that my L2 so I can see which one goes with which. So then for question 2, it says write the let statements and equations that represent alligator 1 and alligator 2. Well, our let statements, if we look at our tables, you can clearly see month and weight right there, and we know that that usually goes X, Y. You can also look on your graph and see that your x-axis is labeled as months and your y-axis is labeled as weight. So there's two ways you can see what your variables are. So our let statements will be x equals months and y equals weight. Well, if we're going to write the equations of both of them, it's easy whenever you have a graph because you can see the y-intercept and your slope to start with. So for alligator 1, we know that by looking at the table, our y changes by 1.5 each time, and our x changes by 1. So our slope is going to be 1.5 over 1 for that. So now if I go down and start my equation, we know that it's going to be y equals 1.5x, and looking at my y-intercept for alligator 1 starts it at 4, so it'll be 1.5x plus 4. Then for alligator 2, same thing, I'm going to go look at my slope, and I see that my y is going up by 1, and my x is also going up by 1, so I just have a slope of 1 over 1, which is the same thing as 1. And then for my y-intercept, I see that it starts at 0, 6, so when we write our equation, it'll be y equals 1x plus 6, or x plus 6. It's the same thing. The next question asks us, what is the initial weight of alligator 1 and alligator 2? Well, we know that initial weight just means what weight does it start at, so we can look at our y-axis, which is weight, and we'll see at our lines here, alligator 1, our L1, starts at 4 pounds, and alligator 2 starts at 6 pounds. And then for growth rate, we know rate is just another word for slope, and we've already found our slope for each one. We have a slope of 1.5 and a slope of 1. So for alligator 1, our growth rate, or our slope, is going to be 1.5, and then now we need to label it. So if we know that a slope is y over x, we just label it as my y value over my x value. So we know that the y is weight, and the x is months. So whenever I write my rate, it's going to be 1.5 pounds per month. Similar for alligator 2, it's just going to be whatever our slope is, and we said it was 1 over 1, or 1, so my rate there is going to be 1 pound per month. And now it asks us what happens at the 4-month point on the graph. So if I look at my table up here, it doesn't quite get to 4. Both of them stop at 3 months. But since we just graphed it, we can look over here, and if I go to my graph at the 4-month period and I draw and I look up here, we'll see that that's the intersection point. And at right there, both of the alligators weigh 10 pounds. So we can say at the 4-month point on the graph, the lines intersect and the alligators are both 10 pounds. We can also see this by using our tables. Since we know the slope of both of the lines, if I look at alligator 1, and I see that the line is going up by 1.5 on the y each time, and 1 on the x, our next term right there would be going up 1 on the x, so I have 4 months, and then 1.5 plus 8.5 gives me 10. So that would be my next point there. And if it was for alligator 2, I'd see that my y goes up by 1, so 9 plus 1 would give me 10, and my x goes up by 1, so that next point would be 410. So if you're given a table, you can see that the intersection point is going to be the only place where it's the same value on each table here. So there are 2 ways to figure that out. And now for number 6 at the bottom, the best way to do that is understand how the variables are split up. We know that time is going to be our x, but then now we've got 2 values for height. So we have a y1 and a y2. So it's really similar to the top problem, except there's 2 tables there, and this one has 1. So what we can do is just write it as 2 tables. So I just took this because the x values is the same for each table, for each tree, and then we've got a different y value. So my y1 is for my tree 1, and my y2 is for tree 2. So now let's just look at the slopes of each one and make an equation out of them. Well, we can see from tree 1 that my y value goes up 1.5 each time, and my x value goes up 1, so we'll have a slope of 1.5 over 1, or 1.5x. And my y-intercept is at 0, 3, so our equation there is 1.5x plus 3. And then for tree 2, our y value goes up 1, and our x value also goes up 1. So our equation here is going to be x plus, and my y-intercept is at 0, 6, so it'll be x plus 6. Well, if you look at our answer choices here, the only one that looks like that is going to be D, because we have our 1.5t plus 3, or 1.5x plus 3, and then our x plus 6, and here's that t plus 6. But instead of t's and h's, I just used x's and y's. Then go ahead and flip the page over and look at the last example here that we're going to do. It says the charges for 2 satellite radio services are shown in the table below. So we've got service 1 and service 2, and again, what I'm going to do is just go ahead and call it service 1, so we'll call that S1, and service 2, we'll call it S2. So when we're going to graph our lines, we know we've got x's and y's on each table, so there's x and y there, and we've got x and y on this one. So now let's go ahead and take a second and plot both of our tables on our graph. So after you get them graphed, let's go ahead and look at what the variables represent. We know that x is months and y is cost, and we can also see that on our graph. Our x-axis is labeled months, and our y-axis is cost. So our let statement is going to be x equals months and y equals cost. So we just graphed them for 8. Now 9 asks us to use the graph to determine which month the service was the same for both companies. We can look at it and see that they don't intersect until they get all the way up here, and they're going to meet right at the 5-month mark there. So they're going to intersect 5 months. So I'm going to draw a line up from 5 months, and then we can look over and see that they're both going to cost $70. So our answer there is going to be $70 at 5 months. Now we can also figure this out by looking at the tables as well. We know that my slope here is going to be 10 over 1. So if I find the next point here, 60 plus 10 is going to give me 70, and 4 plus 1 is going to give me 5. So there's my next point for that table. And now for the table over, well, 26 to 37 is 11, 37 to 48 is 11, so my table is going up by 11 each time on the y, and 59 plus 11 is also going to give me 70. And then for my x values, I have 3 and 4, 2 and 3, everything is just plus 1, so 4 plus 1 is going to give me 5. So here again you can see that the only 2 values that match are 5 and 70, so that's going to be the solution to those 2 lines. And that's the last one that we've got for you. I don't think we need to work through 10. If you want to practice that one, go ahead and look at your y-intercept and your slope of both lines and see which equations match that. But otherwise, y'all have a good weekend. We'll see you on Monday.